Viva, welcome to my YouTube channel. Today we are going to discuss about AWS cloud and infrastructure. So this video series is going to be a part of my bi-weekly assignment, which is also a part of my coursework of doing the certification called AWS Cloud Practitioner Foundational. So please stay tuned to this video and let's dive right in. I'll explain more about what the AWS cloud is. So stay tuned and keep watching. So what is cloud computing? Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on a as-needed basis from the cloud provider like Amazon Web Services, in short form AWS, Microsoft Azure, or Google Cloud. This model converts large capital expenses, CapEx, into small, predictable operational expenses, making it flexible and cost-efficient solution for businesses of all sizes. Traditional IT infrastructure involves significant investment in hardware, software, and dedicated facility spaces. This is followed by ongoing costs for electricity, coding, cooling, 24 hours, IT staff, and more. So today, cloud computing has evolved as one of the largest emerging technologies, which are robust in backup and disaster recovery solutions and are not just in one place. So the types of AWS cloud services and the deploy models. First one is the public cloud. Resources like servers and storages are owned and operated by a third-party cloud service provider like AWS over the public interest. They are shared across multiple organizations. Example, AWS, Azure, and Google Cloud are such of the public cloud services. On the private cloud, you have computing resources are used exclusively by a single business or organization. It can be physically located within the company's on-site data center or hosted by a third-party provider. It offers greater control, security, and customization, but with very higher cost. On the other side, you have the hybrid cloud. This model is a bridges between public and private clouds, allowing the data applications to be shared between them. It provides greater flexibility, allowing the businesses to keep sensitive data in the private cloud while leveraging the powerful computing resources to the public cloud for other tasks. Now let's look at the characteristics of cloud computing. The characteristics of cloud computing are on-demand self-services, where users can automatically provision computing capabilities, and broad network access capabilities available over the network and are accessed through standard mechanisms, examples, mobile phones, tablets, and workstations. And the resource pooling is where the provider computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to the consumer demand. Whereas measured service is a characteristic where the cloud systems are automatically control and optimize resources use by leveraging a metering capability at some level of abstraction appropriate to the type of service, for example, storage, processing, and bandwidth. This enables pay-per-use pricing, which we'll discuss more further coming in the next slides. Now let's talk about the advantages of cloud. Beyond cost savings, the cloud offers unparalleled agility, allowing developers to spin up resources in minutes, dramatically speeding up the experimentation and innovation. It provides elastic stability, scalability, and automatically handle the sudden spike in traffic and so on. The global reach of providers like AWS allows you to deploy and subsidize the cost savings. Moving on further, let's discuss about the cloud service types. There are three types of cloud services basically, which is IaaS, infrastructure as service, as you can see in the diagram. on the bottom of the pyramid provides the highest level of flexibility. You rent the IT infrastructure such as servers, VM storage, networks, operating systems from a cloud provider, and you manage the applications that are runtime on OS, while the provider manages the virtualization of servers, storage, and networking. Example, Amazon EC2, which we'll discuss further in our upcoming slides. On the other side, you have the second one is PaaS, which is platform as service, removes the need to manage the underlying infrastructure, usually hardware and operating systems, allows you to focus on deploying and managing your applications. For example, you could consider AWS Elastic Beanstalk. On the other side, third one is the SaaS, which is software as service. You might have all been familiar with this, which provides complete product and is run and managed by a service provider. You don't have to worry about maintenance or underlying infrastructure costs. You can simply use software, such as in our day-to-day, we use Google, Gmail, Salesforce, and Microsoft Office 365, which are software as a service platforms. Now let's talk about AWS Global Infrastructure. AWS Global Infrastructure is officially launched in 2006 and has become the dominant leader in the cloud computing market, which supports significantly large amounts of virtual services. Uh, it also supports enterprise IT by migrating entire data centers to the cloud to reduce costs. And also, it hosts highly available and scalable websites and web applications and gaming by providing backend infrastructure for game studios handling millions of concurrent players. And also, it supports the mobile and IoT applications by collecting, processing, and analyzing the data from mobile devices and IoT sensors. So choosing a region when using AWS is one of the most important steps, where AWS infrastructure is foundation of its reliability and performance. Regions are physically separate geographical locations, as you can see here in the picture. Currently, we are in the US, where you have US East 1, US West 1. Each contains multiple isolated locations, and the availability zones, which are more discrete data centers within the region, each with redundant power, networking, and connectivity capabilities. They are basically engineered to be isolated from failures and natural disasters. Edge locations and global accelerators are the sites used by Amazon CloudFront CDN to cache content closer to users for faster delivery. Choosing a region is more critical in architectural decision, which can include data sovereignty and compliance. Now let's talk about something called the shared responsibility model. This is a critical security and compliance concept within AWS. AWS is responsible for security of the cloud. This includes the hardware, software, networking, and facilities to run all the AWS services. Whereas on the customer side, on the user end, the customer is responsible for security in the cloud. This includes managing their user access IAM, securing operating systems and applications, and protecting data via encryption and access controls. That's all for now about the introduction about the AWS cloud computing. It's more than just a technological shift, but it's also a business paradigm shift. It empowers organizations to be more innovative, agile, and customer focused by removing heavy lifting IT infrastructure management. The scalability, flexibility, and cost efficiency offers fundamental drivers of digital transformation. That's all for now about the introduction. We'll discuss more about AWS concept in our upcoming video. Thank you for watching. Stay tuned for the next one. We'll be discussing about AWS EC2 and IAM user roles. Thank you for watching.